This is a 2023 AP Physics 2 FRQ. Students are given an unknown circuit component that is connected in series to a resistor with known resistance 500 ohms. The students are asked to experimentally determine whether the component is a resistor or an uncharged capacitor. Complete the following diagram to show how to use standard circuit equipment to determine whether the component is a resistor or an uncharged capacitor. Next bit. Describe an experimental procedure to determine whether the component is a resistor or an uncharged capacitor. Refer to the circuit equipment in the diagram drawn in part A1. Next. What results would the students expect if the component is an uncharged capacitor? Support your answer in terms of potential difference and charge. Next bit. The students conduct a different experiment to determine the EMF E of a battery that is not idle and has internal resistance R is equal to 30 ohms. The battery is connected to a variable resistor in a circuit as shown. The students measure the current I through the circuit for different values of the resistance R variable of the variable resistor that is connected to the battery. The following table contains the data collected. Write an equation describing the circuit in terms of E, I, internal resistance, and variable resistance. What quantities could be graphed to yield a straight line that could be used to calculate a numerical value for the EMF E of the battery? Plot the data points for the quantities indicated in part B2 on the following graph. Clearly scale and label all axes, including units. Draw a straight line that best represents the data. You may use the blank columns in the table for any quantities you graph other than the given data. Using the graph from part B3, determine the EMF E of the battery. This is a DC circuit question. Here he is asking us to find out the circuit component. Okay. And we are given with a 500 ohm resistor and then connecting wires, power supply, and any other circuit, any equipment required, we can borrow from the lab. I give 2 or 3 choices. Okay. So the first one is connecting the voltmeter in parallel with the circuit component. Okay. When you connect the voltmeter in parallel to the circuit component, soon after closing the switch, you measure the voltage. Okay. And then after a long time after closing the switch, again measure the voltage. This is one method. Second method is connect an ammeter in series with the circuit. Okay. After the positive of the battery or power supply, you connect the ammeter. Ammeter should be, remember, ammeter should be connected in series and voltmeter should be connected in parallel to the circuit components. Okay. Because if we connect the ammeter in series with the circuit elements, the current flows through the ammeter. Whatever the current flows in the circuit elements, the same current flows through the ammeter also, and you can measure the current flowing through the circuit. Whereas voltmeter, we have to connect in parallel to the circuit component, because when we connect the voltmeter in parallel, the same voltage will be there between the voltmeter and also the circuit component. So we can easily measure the voltage of the or voltage drop across the circuit component, whatever may be that one. Okay, either at the circuit, this one or this one, wherever you want to measure the voltage. For that, you have to connect the voltmeter in parallel. Whenever you connect the voltmeter in parallel, you are making the potential difference same. Okay, so we are measuring the potential difference across that element. Okay, that is the second one. Now, when you connect the ammeter in series with the circuit element, And then soon after closing the switch, you measure the current flowing in the circuit. And then after a long time after closing the switch, again take the ammeter reading. Okay, this is second method. Third method is take out the ammeter and keep the bulb. Okay, just incandescent bulb. Small bulb will be available in the test bulb will be available in the laboratory that you connect. Soon after closing the bulb, soon after closing the switch, you see how the bulb is glowing. And then after a long time after closing the switch, see how the bulb is glowing. Okay, you have to check the brightness of the bulb. Soon after closing the switch, how bright the bulb is. After a long time after closing the switch, what is the brightness of the bulb? Okay, these are the three methods through which you can check out whether the given circuit component is a resistor or a uncharged capacitor. So that is the one. Next bit, what he is asking is, what are the results? What results would the students expect if the component is an uncharged capacitor? Support your answer in terms of potential difference and charge. Okay. Suppose if the circuit component is an uncharged capacitor, then what happens? I will discuss all the three again. The first case, the soon after closing the switch, the voltage will be 0 if the given circuit component is an uncharged capacitor, because for an uncharged capacitor the resistance is equal to 0. Okay, therefore when the resistance is equal to 0, we know V is equal to IR, V is equal to 0. Okay, so the voltage will be 0. After a long time after closing the switch, what happens? The capacitor gets fully charged. Once the capacitor is fully charged, the voltage across the capacitor will be same as the supply voltage. Okay, this is one thing. Suppose if it is a resistor, then what happens? Soon after closing the switch, the voltage will be something, whatever may be the some resistance, so it will show some voltage. And even after long time after closing the switch, the voltage will be the same. The voltage will not change across the resistor. That is the thing. Okay. Now, next thing, second one, you are connecting the ammeter. Okay. So, soon after closing the switch, what happens if the circuit element is an uncharged capacitor? It will read the current, some current, whatever the current flowing in the circuit, that current it will read. After a long time after closing the switch, if it is a capacitor, once the capacitor is fully charged, it acts like a switch and open switch, and then the circuit will be open. And the ammeter shows 0 reading. Okay, this is indication that the given circuit component is a capacitor, uncharged capacitor. Suppose if it is a resistor, the current will be the same, no? Whatever the maybe the resistance, it will stay same. Soon after closing the switch and after a long time after closing the switch, the resistance will not change. Therefore, the ammeter reading will be the same. And then the third one, suppose if you keep a bulb, then if the circuit component is a uncharged capacitor, then soon after closing the switch, the bulb will glow bright. And after a long time after closing the switch, the bulb will be, the brightness of the bulb will glow out. Okay, that will not glow at all. That means that its brightness comes down. Why? Because soon after closing the switch, the capacitor is not is not charged, uncharged capacitor. No, therefore the current flows through the bulb, and then the bulb glows bright, maximum to brightness. Okay. And after a long time after closing the switch, what happens? The capacitor gets fully charged, and then it acts like a switch, and then the current no longer flows through the circuit. Therefore, the bulb will go out. Okay, suppose if it is a resistor, then the brightness of the bulb will be the same through and through. So these are the three different ways you can find out whether the given circuit element is an uncharged capacitor or a resistor. Okay. Now we will go to the next bit. Next bit here, And this is another experiment the students are conducting, wherein you have a variable resistor and then the internal resistance. So the battery has some internal resistance. Ammeter is also closed. The circuit diagram is given to us. And then they collected some data, and then the data points are given to us. That means current and the resistor, variable resistance values are given to us. Now he is asking us to write an equation describing the circuit in terms of voltage, internal resistance of the battery, and then the variable resistance, and then the current. Okay. So we know according to Ohm's law, V is equal to IR. Am I right? I is the current flowing in the circuit and R is the effective resistance of the circuit. Here the effective resistance is variable resistor plus resistance of the variable resistor plus the internal resistance. Therefore, the voltage here, the voltage of the power supply is E. Therefore, E is equal to I times R plus R. So this is the equation for describing the circuit. Next, he is asking us to draw a graph between the uh, draw a graph to find out the EMF of the battery. How to draw the graph to find the EMF? We have to find out EMF. Okay, so EMF is proportional to current. Okay, so we to find out that the slope should give the, so obviously this is the Ohm's law circuit, no, Ohm's law equation. So V is proportional to I. Same thing, E is proportional to I, and then this resistance is the proportionality constant. So to find out the E, what we have to do, we have to either draw 1 by R plus R times I, or inverse of the I into I, either we have to draw this graph. That means on the horizontal axis, we have to take inverse of the resistance, and then on the vertical axis you have to take the current. Okay, so that the rise over run, that means the slope directly gives the E. Understood? So from this equation, you see the equation E is equal to IR. No, yeah, I are supposed to find out V. So therefore, V by R is equal to I. Am I right? But here you are trying to find out V. So to find out V, what you have to do, you have to take the slope. Am I right? So the graph should be V versus I versus 1 by R. Am I right? So here this is the effective resistance. I versus effective resistance graph gives the E value. The slope of the I versus the effective resistance graph gives the EMF of the battery. Okay. So here internal resistance is 30 and then variable resistance is given to us. So I just put R by R here. You calculate 1 by R plus R and then check my graph. I did the graph on my own because the net connectivity is not that much good here. And because of the slow net, I can't draw here. It takes a long time. And sometimes it may go out also. Then the making the video will become difficult. That is why I already calculated that, drawn the graph outside and then pasted here. Therefore, the slope gives the slope values also I kept here, and from the slope I got this value. Okay, this is the answer for this question. Hope this helps. If you have any doubts, you put in the comment section. I will answer those questions. Okay. Thank you. Bye bye.